Okay, last two rules of differentiation. And then I have an extra one. Technically, you do need to learn this, but I doubt they will ever have a question on this because it is something called too hard, right? I don't think it's hard. It's just you need to learn how to prove this before you actually know how to do it. So, for the inverse function, to remember the proof for this, you just have to do something like this, right? Let's say I have f of x, and then I have g of x, but g of x is actually the inverse function of x. Sorry, not 1, this is x. So if I write something like this, right? This is the function here, this is the inverse function, so this will just turn out to be x. If I differentiate this, differentiate the outside, so this would be f dash and then g x here. So I differentiate the outside and then I would differentiate the inside, right? And then here I would just get 1. So I will isolate the g dash x. So g dash x will be equals to 1 over f dash, and then inside is g of x. And if you remember, here, g dash x, gx is inverse function of this. So this is the same thing as saying d dx and then inverse function of x. Okay, so here I'll just write this as 1 over f dash, and then inside is inverse function. That's how you prove it. You don't have to remember the proof, you just have to remember this, but I remember the proof and then I prove this. So, you do you, Or you could just remember both, but, the syllabus for Calculus AB is not that long, and you probably don't want to make it longer. So, that's the reason why. For the absolute value of this, you have to remember that what is absolute value, right? Absolute value is just this. I just squared and then I root it, and this basically makes sure that my answer it will be positive. That's the same thing as absolute value, right? So let's say I want to differentiate this. Okay, I differentiate this. So what I would do first is I would rewrite this as 1 over 2, so it's easier. Technically in differentiation, I would combine these two powers first, but let's not do that, and then let's just do chain rule first. So this 1 over 2, and then the back would just be this, and then this was minus 1. And if you remember chain rule, I differentiate this, now I just have to do the inside part, and this would be times 2x. Okay, so I simplify this and this cancel. This would just be 1 over, well, the top would be x, and then the bottom would be the x squared, and then this, right? Yep. And then if you remember, x squared and then square root is the same thing as absolute value. So this would be x over absolute value of x. So here it would be x over absolute value of x. And yeah, so that's it for the rules of differentiation. And if you want to skip the next part, which is a bit extra for you to learn, then it's okay. Alright, so for this, you cannot use the power rule for this. Why? Because x, it's a variable, it's not a number. You know, usually it's n, right? It's n over here, and n is a number. It can be an integer, it could be a decimal, you know, it could be anything, but it's not a variable, right? So here, I cannot use the chain rule. For this question, what I would do is I would take, not y, sorry. I would do something like x to the x power is equals to e natural log of x to the x power. Right? It's something like how I did a to the x power. Something like that. I would differentiate both sides. So d dx and d dx. Right? So this would be x natural log x of x, and then the next part it would be I take x down, this natural log of x. So I differentiate this part. So this would just be using the product rule, and then I take this and then I times 1 over x. I should probably not use this anymore. Yep. And then this is plus. Yeah, take the other side, and then this would be times 1. Okay, so this cancels, and yeah. So this would just be x to the x power times 1 plus natural log of x. So that's your answer, right? And again, you don't need to learn this for AP Calc. By their very vague syllabus, technically, you may have to learn this, but you know, from what I've seen I've seen the AP test from 2010, and they wouldn't go this hard. I'll just say it like that. Alright.